Graphing inequalities. There's a few things we need to think about when we're graphing inequalities. First of all, we need to remember how to graph lines. But what we're going to do is graph what I like to call a boundary line. It would be what you would have if it was just an equal sign. It is your boundary from your solution set and what is not in your solution set, or the values that make your equation true or not true, or your inequality true or not true. Now, we need to know whether to include that line or not. Now, draw it solid if the line is included. Now, how would you know if you're going to include something or not? Same way you'd know whether you include a point or not. If it's less than or equal to, or greater than or equal to, that means you're going to include it. Now we're going to make the line dashed if not included. So that would mean when you have a less than or just a greater than. Now, the next thing is to decide where your solution set is. What makes that inequality true? Now, an easy way to do that is plug in a point or a value. But if you plug in a point, let's say 0, 0 usually works, and if it's true, that is in your solution set. Shade that side. If you get a false statement, that means that's not the side of the inequality, the side of that line that works. We're going to shade the other side. So let's see how this works, because it's really a lot easier when you look at an example. All right, we have y is less than or equal to 4. Now, what kind of line would y equals 4 be? Well, y equals 4 would be a horizontal line. Now, it's a horizontal line, and since this one says less than or equal to, that means we are going to include that boundary line. So we want to make sure it's a solid line. So here's when y is 4. Now, what I want to do is figure out which side of the boundary line is part of my solution set. So since we're just dealing with y's, I only need to pick a y value. So let's pick the y value of 0. Is 0 less than or equal to 4? Yes, it is. So this side of the line is our solution set. That means that every single point down here, if I plug in to the inequality, I will get a true statement. That's what it means to be a solution. Look at this one. X is greater than -1. Now, what would our boundary line look like? Our boundary line is x equals -1. That's a vertical line. Now, since it's just greater than, that means it's not included, so we want to make this a dashed line. So it's a vertical line at -1. Here's the dashes. Now, we need to plug in a value to see which side we're going to shade on. Let's start here. 0. Great option. When x is 0 greater than -1? Well, of course it is. And heck, 2 is greater than 1, 3 is greater than 1, all of them, and greater than -1. All of these are. Now, I should have got my colored pencil because I could have made this a lot prettier. But that's okay. Every point in here has an x value that is greater than -1. Uh-oh. Here we have an absolute value. Absolute value of y. Okay. Well, that means we have 2 boundary lines. Because couldn't y have been 3? Or y could have been -3? All right. Now, are those going to be solid or dashed? Those are equal to, so we're going to make those solid. So I have 2 boundary lines when I have an absolute value. Solid line at 3 and a solid line at -3. Now, let's decide where to graph. And I'm going to pick several y values here. When y is 4, absolute value of 4 is 4. Is that less than 3? No. What about 0? Yes. What about negative 4? Absolute value of negative 4 is 4. Well, that's not less than 3, so this is a no. So here, we're actually shading between our boundary lines. Let's continue. Ooh, absolute value of x is greater than 4. Think we're going to have the same situation? Exactly. We're going to have our boundary lines at x is 4 and at x is negative 4. Now, are those going to be solid or dashed lines? My boundary lines this time are going to be dashed. Here's where x is negative 4. Here's where x is positive 4. And so now let's pick some points. Now that we got two boundary lines, we really have to think about this. X is negative 5. Okay, when x is negative 5, the absolute value of negative 5 is positive 5. Is 5 greater than 4? Yes. What about 0? Is the absolute value of 0 greater than 4? No. What about positive 5? Is the absolute value of positive 5 greater than 4? Yes. So we end up with our shading on this one on the outside edges. I hope that reminds you of when we were doing absolute value equations and inequalities. When we had greater than, we had a gap. Less than, we were sandwiched. Very similar to what we've done before. All right, now let's take an easy one. Just a regular old line. Y is greater than 2x minus 3. All right, it means my y-intercept's at negative 3. Slope is 2, up 2 over 1. Is this line going to be solid or dashed? Not underlined, so that means it is dashed. Now let's figure out which side we're going to shade on. Since 0, 0 is not on the line, that's a great point to pick. 0 is greater than 2 times 0 minus 3. 0 is greater than minus 3. Is that true? Yeah! So we want all the points on that side of the line. Simple enough? Well, what happens when we have more than one on the same picture? Oh, believe it or not, it's just so simple. We graph each of them. All right, so I'm going to make sure I have different colors here so we can really see what's going on. Now, I'm going to look at the first one here very carefully because in my class we haven't covered this yet, but I know we can figure it out. That is y is greater than x minus 1 squared minus 3. So let's talk about this a little bit. It's a parabola. Now your parent function of a parabola is like this and it starts at the origin. But this is moved, isn't it? Do you remember what x minus 1, what subtracting 1 from the x actually does? It moves it right 1. The minus 3 at the end moves it down 3. So we have a parabola that's not at the origin. It has been moved right 1 and down 3. Now, you could also use your calculator if you'd like to find more specific points. But once I get a few, now is this going to be solid or dashed? You see underneath there's no or equal to, so this is going to be a dashed line. It's going to look something like this. Now it's not perfect, and that's okay. We're going for speed right now, for me. Now what about figuring out where to shade? 0, 0 is not included, so let's see what happens. 0 greater than 0 minus 1 squared minus 3. Negative 1 squared is going to give me a 1. 1 minus 3 is going to give me a negative 2. Is 0 greater than negative 2? Yes. Now another way you can think about that is when it's got y on the left side by itself, which way are the y's greater than that graph? Which way do the y's get bigger? Up this way. So can you see that 0, 0 would be included if you went up your y-axis this way? Or above the parabola. Okay. Now luckily the next one is just a regular old line, which we're happy about. It has a y-intercept of -2. It has a slope of 3/2, so up 3, 1, 2, 3 over 2, up 3 over 2, and we can go back, down 3, back 2. It is or equal to, so that means we are going to have a solid line. Goes off and off and off. Now, I could plug in 0, 0, but I want y'all to start thinking of some shortcuts here. If greater than went up the x-axis, less than would mean we need to look down. Up the y-axis, this would be down the y-axis. So it's actually everything below that line. Now, when we're looking for a system, now if it's a system of equations, we'd look for where the lines meet. System of inequalities, I'm going to look for where the shading meets. And do you see where they're crisscrossing? It's right there, right between the two of them. That would be my solution set. Now sometimes I also like to put a little S, not for super, but for solution. And that helps too. Let's look at one more. Ooh, we should know this one. Everybody in my class should know this one. That is an absolute value function. What does it look like? That is a V shape. What's happened to that V shape? It's moved left 2 and down 3. Has the slope changed any on it? No. So it's going to have a slope of 1. How would you know if it changed? The number in front of the absolute value sign. Is this going to be a solid or a dashed V? It's going to be a solid V. So let's look here. That would go -2, so left 2, down 3, slope of 1, solid, easy, easy, and the other way. Now we need to figure out which way to shade on this one. It says we want the y values that are less than that graph. Less than that graph, that would be going this way. So it's underneath. Now if you had colored pencils, you can make this a lot prettier. I'm just going with striping right now, but colored pencils probably would make it pretty. Let's look at the other one. Y is less than -1. Well, that's a horizontal line, and it's dashed. So that goes right here. And we want less than that line, so we want underneath that line. Okay, I want you to think very carefully. Do you see this is only the green? So that's not included in our solution set. The only parts that are in our solution set are where we have these crisscrosses. Right here. Let me get a highlighter. Right here is crisscrossed. Here. Up to there. Not that little triangle though. Over here. Over here. And all of that. What we're saying in this is that every point in that shaded area would satisfy both equations, or both inequalities. It would be a solution set for both. So big S for solution set.